This Late Night Linux Family podcast is made possible by our patrons. Go to latenightlinux.com/support for details of how you can join them. Support us on Patreon for access to ad-free episodes and early releases. That's latenightlinux.com/support. Hello and welcome to episode 139 of Linux Dev Time. I'm Joe.
I'm Amalith.
I'm Kevin.
And I'm Andy.
Good to talk to you all again. Recently, off-air, we were discussing a new feature in the Zig programming language, and that led to a discussion of API design and global variables and some other stuff, and we decided we should talk about it on air.
So to kick this off, the Zig programming language is a new language that's been designed by originally a single person named Andrew Kelly, and it started in around 2015. It tries to be a better C, and I should caveat all of this with none of us write Zig daily. In fact, I would say we're not super familiar with it. However, they're doing a lot of things that are pretty interesting in the programming world. They're trying out some new stuff. One of those was this feature that Joe just mentioned, and it's how they're doing I/O. So they want to pass I/O in as a parameter to all functions that have to do I/O. They do the same thing with like memory allocation as well. You have to pass the allocator in, and it's sort of a functional style, but this got us talking about like, are there API trade-offs to this? Like what are the pros and cons to it? And Andy kind of lit up as well.
Yeah. I got really excited about this. Like I'd seen before that Zig lets you pass or forces you to pass allocators as arguments into functions if you want to allocate any memory. And this, as I understand it, which is not very well, this is about passing in some kind of I/O object that lets you do async stuff, and you can't do it without in this change. And yeah, I got excited about that because I always like to fantasize about designing my own programming languages. And there's lots of cool languages that I've used that do all kinds of exciting things, but they've never done this thing, which I think you should definitely obviously do, which is in your main method, when your program is starting, quite often you're not passed anything or you're only passed in command line arguments. But I think you should be potentially passed in anything that you need. You shouldn't need to access anything from the global environment in order to do stuff, whether that's printing stuff out, getting input in, modifying files, things like that. The same way that I would advocate in any other function. If you use the file system, you should get passed in a file system. I think like that should come from the very beginning of the program. Like, why would the main function be any different? Why are we forcing? The first thing you have to do in most programming languages is access like a global variable that lets you print stuff out to write your Hello World program. Let's not have global variables. Let's just do it better.
Well, when you say you need a global variable to print stuff out, I think if we break that down a little bit, like a lot of people may think, all right, when I write my, let's just say in Python, def main, and then I say print something, like what global variable did I use there?
Yeah, until you start unpacking it and understanding what's happening. And the best way to understand this is if you fire up a bunch of threads and start printing stuff out, and you notice that all your printing gets interleaved with each other because there's a whole load of things fighting with each other to use what is actually underneath the global variable or some kind of global resource, let's say, which is that output stream.
Yeah, so like in that example where your output stream is like the single resource that things can be output to the screen or file or whatever. And all of this stuff comes with a trade-off because in the Python example, right, where you don't even know about that global variable that's happening, like that's for the developer's experience, right? There's less that they have to pass in. And I think, Andy, when you say everything should be passed into the main function or anything that you could need, I've heard people say like, yeah, that's a great idea. Let's do that. And then you start thinking about like all of the things that someone could need. So like I/O is one thing in some way that you could do stuff, but there's also stuff like, yeah, you mentioned your command line arguments, your environment variables. So the environment of the program, time is another thing that could be passed in, the allocator, like there's just so many things.
Yeah. And it gets weird. So maybe it's like the ability to memory map files or, like it could get pretty ungainly. I agree.
Yeah. And so when we go back to Zig, what they're doing here is prior to this I/O change, we mentioned that they require you to pass in an allocator. That's already something that a lot of languages don't require you to do. You can just malloc memory, or you can get memory magically from the system. Whereas Zig says for every function that wants to allocate, you have to pass in an allocator to do that allocation for you. And what I find interesting about that in particular, or just kind of this approach, is that actually has downstream ramifications and effects in the way you design programs. So there's a lot of people that write Zig and are like, wow, passing around this allocator to all of the functions that might allocate is really burdensome, or it's kind of a pain. So they'll find ways to allocate all of the memory they need up front at the very beginning of a program, just do all the calculations they need with that memory and never have to allocate again. And therefore their function signatures are nice and tidy and they're no longer allocating enough stuff. But that has knock-on effects because now they can't fail allocation. They also a lot of times might have some better performance because there's only just this one giant block of allocating memory versus like lots of little ones. There's all kinds of like knock-on effects to this one seemingly simple API design change of, hey, we're going to force everybody to pass in an allocator if you want to actually allocate memory.
Yeah, and I think that part of my motivation here is that I actually want some of those effects, right? So if you are going to write to a file, I think it's good that you need to say up front, I'm going to write to a file, and you're forced to take an argument that says, I'm going to write to a file, partly because it reduces your inclination to write to a file. And that's good because it leaves you with more code that is more pure and easier to unit test and easier to handle generally.
Well, I think it also means like for unit testing, kind of like you just said, you have to pass in the things for that test that are needed. You can swap out stuff because you're having to pass in the environment. You can pass in like a testing file that doesn't actually write to the file system. Maybe it just does something or has some pre-generated stuff. But the fact that you actually have to pass this in with the function itself can absolutely make your testing, I would say, better defined and more robust.
Exactly. And as with almost everything, it turns out what I'm really talking about is how to make testing better.
I was just yesterday writing some code that read a config file from a file system, and I was trying to figure out how to test it. The upstream project prefers tests to use virtual file systems rather than your actual file system for reasons like performance, for isolation, so that your tests don't actually mess with potential real configs on the user's file system. So you can test just the code you mean to, just the paths you mean to, rather than your config accidentally including extra stuff. You can control all of the inputs that go into the function when you're reading from a virtual file system rather than the real file system. And that's easier when you're passing in a file system to read from rather than saying read from the file system, for example.
Exactly. And this is what's so cool, right? Like if your main function takes in the things that it uses, and they could be mocks and not the real thing, then everything all the way out to your main function can now be tested, unit tested, without touching any file system or anything, and you can check whether it really works.
My go-to example for this is always time. So if your code has something like a timer or some sort of like an event loop, you can do things like pass in time to a function that is 1,000 times faster than real human time. So you can force errors to happen or things to happen faster than they would normally happen. And it's all because you're passing in time and not just using like the global system time that's out there. So there's a lot of really cool things that can happen when you do this type of like are forced to pass in all of your arguments in more of a pure style. And in fact, actually, there's a program out there called Tiger Beetle that is written in Zig, oddly enough. And they do a lot of this where they try very, very hard to pass in everything, not just to their tests, but to a real program up front, like the memory, time, environments, all of this sort of stuff, so that they have extremely reliable and performant systems for like a very niche use case that they have. And theirs is, it's like a distributed database for financial transactions, if I remember correctly.
I was about to look them up because I thought I remembered hearing about them, but couldn't remember what they do.
I think they're one of the bigger examples of a modern and production program written in Zig today. So they get a lot of attention. They also have a lot of pretty phenomenal engineers that work on their stuff and that have worked on other big projects as well. So they write some really good work.
But yeah, now we're adding another thing, which I think would be even cooler, which we need to pass into your main function, which is like something to do with concurrency or async or threading. Like, because then if all of that stuff is like explicitly there, your kind of threading manager or something is explicitly there and can be mocked, then you can do all the kinds of cool stuff, which I think they do, which is like deliberately making threads behave in weird ways so that they wake up at unexpected times and you catch all the races and stuff.
Yeah, and with the Zig change that we were talking about originally, like the I/O change, here what's happening is you're passing in an IO object into a function, and that IO object doesn't really specify like how something happens. It's just like that's the object you interact with to write to a file, to write to a terminal, what have you. However, what's interesting about this is you can create this IO object to be either asynchronous or concurrent or synchronous. Like there's all these different ways in which you can create an IO object and pass that in and say, here, use this version of IO. And where that strikes me is like, one, I think it's a pretty interesting way to do IO, but there is some questions around like how viable will this be in a low-level systems language, but just in general, when you may not know whether or not the input-output that you are interacting with is concurrent or asynchronous or synchronous, like you don't actually know what underlies it. And does that make your code behave differently? And should you know? Because then if you should know, well, then passing in, an object for each one of the ones becomes like even more burdensome for no tangible gain, I guess.
That is really cool. Yeah, I did read that, and I haven't got into researching it to figure out how it works. But yeah, my understanding is that it fixes the so-called function coloring problem, where some of your functions are async and some of them are synchronous, and you can't mix them up because you're passing in whether or not it's asynchronous in this IO object. And if that really works, that is very cool because function coloring problem is a real problem.
Yeah, I heard someone say that they solved function coloring by coloring all the functions, which I thought was pretty hilarious. And I think it just speaks to like you're passing in IO and therefore you don't have to care whether it's red or blue. You just know that it's an IO function.
So for people who might not be familiar with function coloring, what is red and blue about? What's the difference between them?
Yeah, it's this idea of some of your functions are asynchronous and some of them are not. And it's something that happens in a lot of languages like JavaScript, I think is where this problem was originally talked about, where especially in JavaScript, it's quite hard to know which is which is particularly difficult. But yeah, you shouldn't really be calling synchronous functions from asynchronous functions and vice versa, at least not without knowing what you're doing about that.
Yeah, and it has to do with the fact that you can't call one color from another, right? Like hypothetically, you can't call a red function from a blue function or vice versa. And even in languages that, Andy and I love, like Rust, that you still kind of have this problem where there is a difference between an asynchronous function and a synchronous function. Yes, there are ways to call one from the other, but looking at the API signature itself, there is still a distinction between a asynchronous function and a synchronous one.
Potentially, you just have to write code multiple times because you need a synchronous version and an asynchronous version, or you do some horrible hack where you write it all as asynchronous and then you just block waiting for it to finish.
Or at least in Rust too, you'll end up in scenarios where you may have like no asynchronous code at all in your code. Like you're actually just writing a synchronous program. And then a particular library that you want to depend on that does something very important requires asynchronicity. And therefore you now have to pull in an asynchronous runtime. You have to call it asynchronously. Like there's all this other stuff that kind of comes with it because one function required the async nature of it. And you might say like, well, I don't actually care. I'm in a synchronous nature. All I really want to do is run the function and that's it. But because at least in Rust, you kind of have to care which one it is in these circumstances like that. That's kind of the side effect. And that's what people are trying to avoid when they say like avoiding the function coloring problem. It means you don't have to care.
Okay, this episode is sponsored by Tailscale. Go to tailscale.com/LDT. Tailscale is an easy-to-deploy zero-config VPN that allows you to build simple networks across complex infrastructure. It's zero-trust network access that every organization can use. And with Tailscale's ACL policies, you can securely control access to devices and services with next-gen network access controls. Tailscale is built on top of WireGuard, and setting it up is really straightforward and quick. All four of us use Tailscale, along with loads of other hosts from the Late Night Linux family shows. I got started in minutes, and you can too. Tailscale's personal plan is free forever. You'll get up to 100 devices and 3 users at no cost, with no credit card required. So support the show and try Tailscale for free today at tailscale.com/LDT. If you'd like to bring Tailscale to work, use code LATENIGHTLINUX for 3 free months of any paid plan. Thousands of companies have already made the switch. That's code LATENIGHTLINUX.
Okay, so all this talk about asynchronous runtimes makes me think of another way in which this kind of principle might help us. I think that basically passing arguments into functions is the answer to everything. It lets you test things, it makes things more flexible, it makes you explicit about what you're using. And Rust has this problem that there are multiple possible asynchronous runtimes that you could be using, and you basically have to choose one or the other, and it's very difficult to mix them. And even the libraries that you use have to be designed to work with one or another. And if we could find a way, which I think some people are probably working on, of passing in the information about which asynchronous runtime you're using so that all those libraries don't actually have to pick one, they can just use whichever one gets passed into them, then again, we solve this kind of global variable problem, because an asynchronous runtime is a lot like a global variable or a global system that's running behind your stuff by just passing in arguments.
I think actually if you even look at some of the asynchronous runtimes in Rust, like some of the macros in their setup, like they legitimately just create a global variable for their runtime that they can call into, which again, like that speaks towards the developer friendly part of it, right? We want you to be able to call a runtime without really having to think about it and just say like, I have an asynchronous task, please run it for me. And that's nice, but it does come with these downsides where if you're using multiple libraries that were built in isolation and they assumed different runtimes or require features of a specific one, that it's very difficult for you to like have them all run in tandem. So it is a trade-off. And I don't think that there's any real one size fits all for this type of a question. And that's honestly why I think even the Zig design, while I think it's very interesting and I'm very, very closely following it to see how it pans out, I am ultimately wondering whether or not it will pan out for all things. Because I think they're going to have to make trade-offs. And I believe there's already been some trade-offs made, like this will work good for these scenarios, but not for others. Or there might be these kinds of edge cases and not these others, right? There's always trade-offs in this type of programming.
Yeah, and I'm like a global variable minimalist, maximalist ranting podcaster who hasn't actually used these things. But I'd like us to try and take it as far as we can. Like every time there's a global variable, hidden or not hidden, we end up paying for it down the line. And I'd just like to eliminate them all.
I've wondered before, like even in systems where you have to pass in something. So let's just take the Zig example of passing in an allocator between functions. And although like I don't write Zig closely more than like a hello world or anything like that, so I might be saying something that's not even correct for Zig, but let's just take it as an example. And like I have to create the allocator somehow or define it and say like, this is my debug allocator or my general purpose allocator or whatever it is. And I pass it in. But what stops something from creating that? Like effectively, that's not a global variable. It's just a local one that's being threaded through everything. But like what stops someone from creating other ones and trying to interleave them? And maybe it's more clear if we're not talking about allocators, but still it just seems like there's nothing stopping somebody from just creating another one of these things, which could induce other problems. But I'm probably like theorizing about stuff that's really not a problem in practice.
Yeah, that seems like a good thing. For example, you could use a different allocator for a different bit of the code or whatever.
There's probably cases where no matter what, right, even if we're passing something through the arguments of a function all the way down, when we get down to like the assembly or something like that, or into the operating system, like there might still be a global context there that has to be called. And I wonder like if there are ways to even avoid that. Now, again, this is kind of like just pontificating, but it's interesting thought.
Yeah, there's a bunch of stuff that really is global when you're down at the system level, right? You know, like, I don't know, the memory or something. So yeah, it doesn't actually quite map onto reality.
In the example of passing a virtual versus real file system into a function to load a config file, it's pretty clear that the caller of the config loading function is the one creating the file system and deciding which one gets passed in. When you're passing stuff into a main function, is there a setup function or something? In that situation, where does the creation happen to pass stuff into main?
Well, here's a funny bit of context, which I don't think everybody is tracking, but like all languages have a runtime. Usually when we talk about a language having a runtime, we think of something like Go or Java or something that have these like, I would say more heavyweight runtimes that are doing things like garbage collection and all this other sort of stuff. And they can do all of the setup and tear down and things for a function, but like even C has a runtime. Rust has a runtime. They might be very, very minimal and do not really a lot, but they still have to do some stuff like set up the command line arguments and set up the like tear down and the allocators. Like there is still stuff that has to happen, however minimally. So you don't really hear it often, but like C has a runtime. So next time somebody tells you like, oh, I don't like using Go or whatever because it has that giant chunky runtime, you should say like, oh, you know, C has a runtime too. So I guess you're opposed to that as well. But that's the thing that does a lot of that setup.
Okay.
Yeah, so that runtime would be the thing that created the stuff. But I actually think it's a really good point, Amleth, because the question then becomes how sophisticated is the thing that you get passed into main. So the ideal from one point of view would be the most low-level possible thing would get passed into you, so that then you could wrap it in whatever style of file system you wanted, or whatever, or you could put a lock around standard out or whatever the thing was. But then that's going to be incredibly awkward to use if you get given the very low-level stuff and your first job is always to like wrap it up into something that's easier to use. So maybe this is all a terrible idea.
Well, I think it would be funny, like imagine if you had a main function that had, instead of just like your arguments passed in, it had literally every possible thing. You would have a main function that could span multiple lines, which would be kind of funny, especially if you didn't have to use all of it. But like that is an interesting thought experiment of how to do things.
Yeah, I kind of imagine you get past a thing called like a context or an environment or something like that. But then the problem is then they'd be really tempted to pass that just into every function, and then every function would have access to everything, and then you just lost all the advantages.
And some of those advantages, like we talked about, come from like forcing people to do something in a particular way with an API design choice that then causes other downstream effects.
But yeah, getting people to think about what dependencies they have by making them accept them as arguments, in general, pushing in that direction feels right to me. I've always said, if you want to use a logger, you should be passing a logger into the functions that use it and not just grab it from some kind of weird global context for exactly the same reasons.
In Go, there are methods versus functions, and methods have access to a sort of shared state. How does that compare to something like a global variable?
So in those cases, in my opinion, that's more local state, because you're still creating an instance of some kind of a struct or a class that has some data associated with it. And then those methods have access to that particular instance's state. So it's not global as in like anywhere in the program you can call into it and get access to that particular state. It is like global in the sense of any of the methods have access to that state, but it's still methods of a single instance. And it's not just accessible anywhere. Mm-hmm. Usually you'll see this in functions or methods that have like a self or a this type argument. Usually it's the first argument. Sometimes some languages hide that and it's just implied. But either way, that's still not necessarily global, even though it might appear kind of global-ish. It's still more local state.
Yeah, exactly. And I'm not so much of a fascist that I really think you have to pass everything into arguments. I'm happy for you to have things that are held in an instance of a thing and you can call methods on it. And I think the real question is like, what harm does it do? That's how you can tell whether it's okay or not, right? And so take the example of passing a logger into every function. Well, I'd be quite happy for you to pass a logger into the constructor of an object and then call methods on it. And the reason why I'd be okay with that is because when you're writing your unit test and you're checking whether the logging is working correctly, you can set that up, right? At the beginning of your test, you create a fake logger, you pass it into the constructor of your object, then you call methods on the object, and you can check whether the fake logger got the log messages it should have got, and everyone's happy. So yeah, that's what harm is there. And where the harm comes in is when you can reach into some kind of global namespace, grab hold of a logger by some kind of magic, and now suddenly your unit test is also grabbing some global logger by magic that you have no control over and you can't test.
Yeah, I think there is some harm in putting a lot of state into those instances as well, because you can end up in scenarios where you effectively have like a long-lived context or state, but not all of your methods really need access to all of that data. And they only need access to like one or two things. And that's just cases where you should probably just break it up further into smaller structs or classes or objects, whatever the language you're using, the terminology that they use.
Yeah, that is a really important point. Like you can end up with things that are not exactly global, but similar to global variables by just having tons and tons of properties that are not actually needed by half of the methods. You end up with this kind of God object that just owns the world and works like a global variable.
There's an interesting use case that I've used as an example before, and in fact, actually it just came up at work recently, where you have the option of either having kind of a global variable or not in a Rust code base. And this one, it was a trivial example of calling something to print in a loop. And in Rust, you can just call like the print line macro, which looks like that's effectively the global variable variant, right? You just kind of magically call this print line thing and it shows up in a terminal. And then there's a slightly less global variable-y style where you can actually create an instance of standard out, like an object that represents that one thing. You can then lock it before the loop, print all of your stuff in the loop, and then unlock and flush it. And that has like way better performance. And in fact, actually, that's one of the like foot guns of Rust. If you were to just translate something directly from, say, Python to Rust, a lot of people run into this issue. But it can show that like there's a lot more control and there can be more performance when you're doing all of this extra work, i.e. like creating the object that represents the IO, locking it, doing the printing, flushing it, destroying it, all of that sort of stuff. But it's also just like a lot more cognitive load and things you have to look at on the page, things you have to read versus just calling a simple like print method. So there are pros and cons, and that's why I keep saying like it's kind of a trade-off depending on which one you want. Do you need performance? Do you need control? Do you want to force people to use a particular pattern, or do you want like purely just developer experience?
So generally, when I set up a command line program in either Python or Rust these days, I will write a very dumb main method, and all it does is makes like a writer or whatever, a reader or whatever things you need to wrap around standard out and standard in, and then I'll pass those in as like mockable arguments into all the other functions in my program. So then I can test almost the entire thing, and it's like quite a lot harder to do, especially in Rust, because you've got to get the right trait, like for the right reader type that trait's implemented by standard out and standard in and stuff like that. But it's such a pleasure to use once you're in there. And I guess partly what I'm asking for is like a bit more language support for that to make it more natural.
Yeah, I do the exact same thing, and it allows for like testing IO much easier. So you can like compare, in a test, you might just write to a string buffer in memory, and then you can compare that to something you arbitrarily create in your test versus like writing to a terminal. Like that's a lot harder to test in. So for like really command line heavy programs, that's exactly what I do as well. I'll create something like that at the beginning and just pass it around.
And you end up with, in your toolbox, you just have a list of tricks of like, oh, I happen to know that like, I think string implements read in Rust. Is that right? Something, anyway, or something like that. Like you learn like the ways of quickly setting this stuff up so that it's natural, but it takes a bit of getting used to.
Right, well, we better get out of here then. We'll be back in a couple of weeks, but until then, I've been Joe.
I've been Amalith.
I've been Kevin.
And I've been Andy.
See you later.